Structure of the Earth. The Earth can be divided into three main sections. The core is at the center of the Earth. The core is extremely hot, about the same temperature as the surface of the Sun, and made mainly from iron, which gives the Earth its magnetic field. The core's center, the inner core, is solid, while, surrounding this, it is liquid, the outer core. Around the core is the mantle. This is made from magma, rock that is mainly in a viscous state. Nearer to the core, the magma is under higher pressure, so it is less fluid. Nearer to the crust, the mantle becomes less fluid again, due to the comparatively lower temperatures. This causes it to gradually merge with the core. The surface of the Earth is called the crust. This is the solid rock that floats on the mantle underneath. Crust can be one of two types. Oceanic crust is thinner and denser, and as the name suggests, has ocean above it. Continental crust is wider and less dense with land on the top. Convection currents. Molecules in a gaseous or liquid state can move. If they are heated, they move faster, spread out, and move away from the heat source. If the heat source is below, this will cause the molecules to rise and become less dense. The hot place where the molecules started from will draw in higher density molecules from either side of the heat source. As the molecules move upwards, away from the heat source, they become colder and denser and will start to sink again. They don't sink in situ, because newly heated molecules underneath are moving upwards, forcing them to move to the sides. They then sink back down, where they are drawn in towards the heat source to be reheated again. This completes a cycle known as a convection current. Continental drift. It is convection currents that drive the air to move as wind and the sea to move as ocean currents around the globe. It is also convection currents that cause the mantle below the Earth's crust to move. Molecules in a gaseous state, such as the air, can move very quickly due to their low density, whereas liquids, such as the oceans, move more slowly due to their higher density. In relative terms, magma is extremely dense and viscous, so moves very slowly, sometimes just a few millimeters each year. The hot core heats the magma above it, causing it to rise upwards towards the surface where it becomes cooler and denser. It is now forced sideways due to more rising magma beneath it. This continues until the cooler, dense magma is able to descend back to the core to be reheated and complete the cycle. As it moves sideways, the attached crust moves with it. The section of crust above laterally moving magma is known as a plate. Plates meet other plates at the boundaries of the convection currents in the mantle below. Where plates meet is called a plate boundary or margin. It is at plate boundaries that most tectonic activity, such as volcanoes, earthquakes, and mountain building, occurs. The type of tectonic activity that occurs at a plate boundary depends on the type of crust of the two plates involved and their direction of movement relative to each other. Some plates and their boundaries are easy to identify, while with others it is less so. Plates might be meeting each other at an unusual angle, so don't fit the usual categories of the types of plate boundaries. In some places, there may be smaller plates called microplates, while in others, there might be bits of crust that have broken off at some point in the past. In other places, bits of crust from older plates have merged to become part of another plate. Sometimes, there may be stretching of the crust and the beginnings of rifting to form wide valleys on land or even ocean. The true picture might be concealed by ice, rock, or ocean, so that it is difficult to study. All these things make it difficult to make sense of what sometimes appears chaotic. Academic thought develops all the time in the study of plate tectonics. The map is an attempt to summarize the main tectonic activity and plate boundaries in Europe.